We're on the back of page 55. And we are going to start with problem 2. These will not take us very long, so then we will move over into the hyperbola. So let's get our notes out. And we're on the back of page 55, where it says write the equation of the ellipse. Now, for number A, I have a bad problem for number A. So for number A, where it says major axis equals 12, add on in the horizontal direction. So, stop. We're in our notes. We're on the back of page 55. Problem number 2A, where it says the major axis is 12, add these words. Okay, get your notes out, sweetie? Good job. Add in horizontal direction, where it says the major axis is 12, in problem 2A. Now in a minute, you'll see why that's necessary. The problem's really not doable without adding that. All right, so our job is to write the equation of the ellipse. Now, it's still on the board from the quiz. An ellipse has an x parentheses over something, a y parentheses over something equal to 1, right? So basically, when you're writing the equation of an ellipse, you're looking for 4 numbers. The 2 that make the center, and then these guys, which tell you how far up and down and sideways to count, right? So what do we know? The center in this first problem is at -2, -4. Okay, wait a minute. -2, -4 is the center. Can I fill anything in my equation? Yeah. Yes. X plus 2, y plus 4. Now, it tells me that my minor axis is 10. All right, now wait a second. If it's 10 units long, that means you must have gone one direction 5 and the other direction 5, which means your denominator had to be 25. This is like a puzzle. We're thinking backwards, right? So one of my denominators is 25. What's the other denominator? 36. Now, it says we added the major axis is horizontal. So that means the 36 goes where? X. Under the X. If I didn't add this on, do you see how you wouldn't really know which one was the 36 and which one was the 25? Mm-hmm. So I had to make that change because I had a bad problem. All right, well, that wasn't too bad. Let's do the next one.
That's it.
That's it. You're done. Done. This is your equation right here. This is your answer right here. All right, so now the endpoints of the major axis are at -2, 2 and 12, 2. And the endpoints of the minor axis are at 5, 5. Thank you. And 5, -1. So there's a picture of my ellipse. Now, your job is to write the equation. So just like before, it's an x parentheses over something plus a y parentheses over something equal to 1. Every ellipse equation is going to look like that. And you have to figure out from this picture, what are all of these numbers? Anybody have a thought? Liam?
Well, I sort of just looked at the endpoints and saw which numbers were the same. Just thought, it's probably what.
Exactly. If you drew in, let's say we drew in our major axis, what do these 2 points match on? They have a y coordinate of 2. So your center is going to have a y coordinate of 2 because it's going to match these. Now what about up and down? What matches up and down?
5.
So your center is going to match that. So your center is at 5, 2. So x minus 5, y minus 2. Now what about the denominators? You know your center, right? How far did I count over here? 7? Well, if I counted over 7, then there has to be a 49, and where do I put it? Under the x. How far up did I count from here to here? 3? So that means this number must be a done. Is that okay with everybody, or is that doable for you? All right, last one. These are pretty easy, I think. All right, here we go. There's another one. Oops, missed that point. Not a very good picture, but you get the idea. Here's our equation. X parentheses squared over something, y parentheses squared over something equals 1. Let's see, who hasn't spoken today? Kervin, can you fill in any of those blanks?
X minus 4, y minus 1.
What does everybody think? Are you in agreement with him? Yeah, that's the center. Perfect, beautiful, wonderful. All right, Daisy. Can you figure out either denominator? What? 16? What? Where do I put 16?
X, no, Y.
Why? You're starting at your center, Daisy? Are you counting sideways or up and down? Which way? Up and down right now? Okay, so we're going from 4, 1 up to 4, 4. So how many steps would that be?
3.
Okay, so it's a 9, and since you're going up and down, that 9 would be under Y. Now, Daisy, you get to redeem yourself here. Let's go sideways. 25, beautiful, perfect, absolutely. Anybody have a question about that?
Why would the 4 and the 1 be negative? Why would it be x minus 4 and y minus 1?
What do you think it should be?
I mean, I was just wondering like why they're both negative.
Well, these are both positive. And remember, in the parentheses, it's the opposite of the center. Okay? Ready? Here we go. Now we're going to start with the last of our curves, and it's the hyperbola. So we are on page 56. Can anybody tell me what is different about this equation? What? There's no parentheses. Okay, that just means 0, 0 is the center. All right. What else is different about it, Raven? It's a subtraction. Oh my gosh, groupies, that's huge. When there's a subtraction, it's a hyperbola. Now, I need everybody paying attention. This is the toughest one. This is the most complicated curve. Our job, I'm going to make a list so I keep track of it. Our job is to find the center, the vertices, the foci, the asymptotes, the transverse axis, and the conjugate axis. Now, some of these words you don't even know what they mean, and we'll get to that. We'll talk about it as we go through. But the center, you do know. And in fact, we already talked about it, kind of some of you already said. The fact that there's no addition and subtraction means your center is at the origin. All right, so here we go. I'm going to ask you to draw this first one with me. I think it's important that you draw at least one of these to get a feel for what's happening. So here's my center. If this were an ellipse, what would this 9 tell me to do? Sideways 3? So that's what I want you to do. I want you to count over 3. You don't have to label them. Just count over 3. Okay? What would that 16 tell you?
Up and down 4.
Up and down 4. Now, at this point, if it were an ellipse, we would join those 4 points with a nice oval, right? Not with a hyperbola. With a hyperbola, you're going to take those same 4 points, but you're going to make a rectangle. Make a rectangle through them, okay? So you're using the very same 4 points, but you're making a rectangle instead of an oval. Love you, dear. Okay. Now, once you get that drawn, I want you to draw in the diagonals using dashed lines. I want you to draw in the diagonals of the rectangle. Okay, does everybody see what I mean by that? Now, do you even know what a hyperbola looks like? When I use the word hyperbola, do you know what I'm talking about? A hyperbola is something that looks like this, or like this. Okay, it's like 2 parabolas facing opposite each other. Now, we are going to draw a hyperbola in between those lines. These asymptotes, these diagonal lines are called the asymptotes. Let me write that down. These are called the asymptotes. Notice there is 1 P in the word asymptote, and it's silent. So don't say asymptotes. That's like my pet peeve. There's no P at the end of the word, and the only P in the word is silent. They're called asymptotes. And they are going to frame your hyperbola. Now, what we have to decide is this going to be one that goes sideways like this, or is it one that goes up and down like this? The key is whatever letter comes first in the equation. Since X comes first in the equation, my hyperbola is going to look like this. It's going to start right here at the edge of the box, and it's going to follow those asymptotes out. Okay? Now, while we're here, I'm going to tell you one of my favorite all-time stories. Has a beautiful black t-shirt up there that on the front says "Got Math." Class of 2009. I think it was class of 2009. I taught IB Math at the time, and so I had the kids for 2 years. IB Math back then was a 2-year program, so I had them for 2 years. Their senior year, they were getting ready to graduate. It was about this time of year, actually later. They were getting ready to take their exam. Well, no, before that, for the Math League shirts that year, they came up with a plan. I presented it to the administration. The administration turned it down. Said, no, can't do that. Their plan was that shirt up there. And so the kids, unbeknownst to me, went ahead, that class went ahead and had them made. And on their last day of school, when they came in to take their exam, they all were wearing those shirts and gave me one that day. The front says, got math. The back says, you bet your asymptotes. I thought this was cute. I liked it. But obviously I don't have that side showing because the admin told me I couldn't have that shirt. So this is all on video. It's a cool shirt. I wore it to all their graduation parties. Okay, so now I know I got my parabola or my hyperbola, and it opens sideways. Now, what was my clue that it opens sideways and not up and down? The letter that comes first. This is always going to be a subtraction problem, so it's always going to be something minus something. If it's x squared minus y squared, it opens sideways. If it's y squared minus x squared, it's going to open up and down. So you would have this hyperbola. These 2 points right here where it touches the box, those are the vertices. So our center was the origin. Our vertices are 3, 0, and negative 3, 0. So you're going to draw your box, you're going to put in your diagonals, and then it's either going to open at the top and the bottom of the box, or at the left side and the right side. This one's left and right. So these 2 points are our vertices. These 2 points are nothing. They're not on the curve. They're not part of the green picture.
But if it was y, that was straight.
Yep, those would be the vertices. Yep. Now, this axis that connects your vertices is called the transverse axis. It joins the vertices. So in a hyperbola, you're going to be asked for the transverse axis. Well, once you know where your vertices are, then you can tell me how long that is. How long is my transverse axis? It's 6. Now in an ellipse, we have major and minor. And that's all about length, right? The long one's the major, the short one's the minor. In a hyperbola, it has nothing to do with length. It's which one joins the vertices. Vertices. Transverse vertices. This other axis is called the conjugate axis, or the partner, the helper axis. And the conjugate axis in this problem is 8. The axes of a hyperbola are kind of just the dimensions of the rectangle. The transverse is the one the vertices are on, the other one is the conjugate.
Where the 8?
You went up and down 4 when you built the box.
Yeah.
Now, I bet you can guess that the foci are here. They are inside the hyperbola, just like they're inside the ellipse, just like they're inside the parabola, or the focus is inside the parabola. Tell me, remember this is the point negative 3, 0, this is the point 0, 0, this is the point 3, 0. Tell me what you know about those 2 focus points before we even do anything else. What do you know about them? Y is 0. Half credit, Y is 0. In a hyperbola, the distance from the center to the focus would be the square root of 9 plus 16. So in other words, I'm using the same numbers, but this time I am adding them. I'm using my denominators and I'm adding them. So what do I have? 9 plus 16 is 25, the square root of 25. is 5. So that means you're gonna start at your center and go forward and backward 5. So where are you gonna be? -5 and 5. No, it is always, Quincy asked a great question. In a hyperbola, in an ellipse, everything starts with the center. Don't be using these other points. It starts at the center. Ellipse and hyperbola both, everything builds from the center. All right, now the only thing left is what is the equation of the asymptotes. Now, these asymptotes, these red lines, are lines. So we're going to be doing y equals mx plus b. They're lines. In order to do that, we need to know a couple of things. We need a couple pieces of information. What kind of information do we need if we're going to write the equation of a line? We need a slope. Stop right there. You already know the slope. When you built this box, they created these red lines. You started right here at this point. How far up did you go? How far over did you go? What's the slope of that line? 4/3. How about this one? You still went up 4, but you went left 3. So one line has a slope of, we got this already, I need more space, I'm gonna erase all this. One line has a slope of 4/3, and one line has a slope of -4/3. Do you suppose they'll always be opposites of each other like that? Yeah, because when you build the box, you're either going to go up and left or up and right, right? So it's going to be the same number. One's positive, one's negative. What else do you need besides the slope? Well, you need a point. It may or may not be the y-intercept. You may have to figure that out, but you need some point to plug in. So what point do I know for sure these lines go through? The center. So I'm going to use the point 0, 0, or whatever your center is. Your center might be something else. Y equals mx plus b is my framework. This good review. Remember how this works? This is x, this is y. 0 equals 4/3 times 0 plus b. What does b equal? 0. So this line is y equals 4/3 x plus 0. mx plus b. What about this one? 0 equals -4/3 times 0 plus b. Isn't it the same thing? So here are your two asymptotes. All right, those are massive problems. You guys have done a good job staying with me through that. We'll do some more of that next time we're together. Okay? You have your homework sheets. It's posted in Schoology. You really need to use the next 4 days to get going on some.